warm welcome for the Head of Chemistry Department, Dr. Asep Saifullah. Dr. Asep Saifullah, the time is yours.
Terima kasih. Good morning, everyone. I prefer to speak in bahasa. Oke. Pertama-tama saya ucapkan terima kasih kepada para mahasiswa yang sudah berkenan hadir di tengah kesibukan penelitian dan kuliah pada pagi hari ini. Assalamualaikum warahmatullahi wabarakatuh. Kita ucapkan terima kasih kepada tim yang berkunjung ke Departemen Kimia, Bapak Dede Heri Yulianto dari Pusat Riset Mikrobiologi Terapan, Badan Riset Nasional, kemudian Dr. Muhammad Anwar Muhammad Iqbal PhD dari School of Chemical and Malaysia, and also his friend Dr. Marimara from India, ya, is Green, ya, doing research or postdoctoral research, and later on also will deliver talk in Department of Chemistry. Jadi rekan-rekan mahasiswa sekalian yang hadir di ruang ini,
sampai sebegini ini udah cukup.
Juga yang hadir secara online, para peserta kuliah tamu pada pagi hari ini, kami merasa ini merupakan satu topik yang sangat menarik, ya, di samping topik-topik yang pernah dan juga akan kami hadirkan sebagai kuliah tamu atau juga umum yang berkaitan dengan bidang kimia. Kali ini adalah tentang mitigasi alga yang berbahaya, dikatakan harmful algal bloom. Ini merupakan suatu problem di lingkungan, di bidang lingkungan terkait dengan masalah ledakan alga yang sehari-hari kita juga sering melihat masalah ledakan eceng gondok di sistem akuatik, ya, di lingkungan di sekitar kita. Ini adalah ledakan alga yang kalau kita lihat nanti dari slide Dr. Anwar Iqbal itu akan terlihat bagaimana sistem akuatik danau, waduk, ya, terkontaminasi nutrien yang sangat tinggi. Akibatnya terjadilah ledakan alga yang menyebabkan masalah di lingkungan yang sangat serius, ya. Ada recreational value yang hilang di sana, economical value, biodiversity value juga hilang di sana. Dan kali ini Dr. Anwar Iqbal akan menghadirkan sisi riset dari perspektif seorang kimiawan. Di samping tentunya bidang ini juga menjadi bidang kajian dari teman-teman periset dari bidang biologi dan juga biokimia. Sekali lagi saya ucapkan terima kasih para mahasiswa dan peserta yang hadir secara online maupun offline. Dan also thank you Pak Dede dan juga Dr. Anwar Iqbal. Thank you.
Thank you to Dr. Asep for the warm welcome. And furthermore, we will hear a warm welcome for Dr. Dede Heri Yulianto from National Research and Innovation Agency. Dr. Dede Heri Yulianto, the time is yours.
Baik, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Yang kami hormati dan banggakan Pak Dr. Asep beserta jajaran dosen di Departemen Kimia UI, juga Dr. Anwar dan Dr. Manimaran yang hari ini sebagai guest lecture, para mahasiswa yang hadir. Jadi pertama-tama saya menyampaikan ucapan terima kasih, ya, atas hospitality-nya dari Departemen Kimia UI mengundang kami ke sini untuk bisa sharing activity sekaligus juga membuka peluang untuk kolaborasi. Nah, saya sedikit agak panjang hari ini ingin menyampaikan dua hal. Satu terkait dengan BRIN, Bapak Ibu. Jadi BRIN atau kalau Inggrisnya dan National Research and Innovation Agency itu sebuah platform baru ya dari gabungan entiti dari LIPI, Batan, BPPT, LAPAN, dan teman-teman peneliti di kementerian, ya baik pertanian, perikanan, kehutanan, dan sebagainya itu gabung satu menjadi BRIN. Sehingga BRIN saat ini sangat besar dan kita punya banyak lokasi. Salah satu yang terdekat di sini adalah di Cibinong dan di Serpong. Ya. Di Cibinong kita punya fasilitas lab yang cukup lengkap dan kita punya banyak program termasuk alat-alat dan kegiatannya. Kita punya namanya ELSA, E-Layanan Sains. Itu terbuka untuk teman-teman kolega dari dosen ataupun para mahasiswa yang ingin menggunakan. Jadi prinsipnya setiap peneliti BRIN itu punya virtual money. Ya, selama dia menjadi peneliti, di awal tahun dia diberikan 20 juta. 20 juta itu digunakan untuk seluruh pengujian yang ada di BRIN, semua di seluruh Indonesia. Jadi kita bisa gunakan termasuk yang di Serpong, Bandung dan sebagainya kalau tidak ada, menggunakan virtual money itu. Nanti melalui publikasi itu bisa di top up. Ya, bisa top up. Misalkan Q1 itu top up-nya 10 juta. Sehingga banyak peneliti-peneliti yang kemudian dia semacam punya tabungan. Gitu. Jadi ada yang 500 juta elsanya, sehingga itu bisa leluasa menggunakan fasilitas alat-alat yang ada di BRIN. Jadi kami membuka kolaborasi untuk teman-teman dosen ya untuk memanfaatkan fasilitas ELSA ini ya silakan nanti untuk bisa kolaborasi bersama ya. Termasuk nanti untuk para mahasiswa, nah ini untuk dari sisi saya sendiri kita juga buka kolaborasi barangkali nanti dari teman-teman dosen kita melakukan pembimbingan bersama. Termasuk saat ini kita punya apa yang disebut dengan program post. Saya misalkan mendapatkan postdoktoral dari India, Dr. Manimaran. Beliau melamar karena beliau baru lulus. Jadi syaratnya adalah lulus tidak lebih dari 5 tahun. Itu menjadi postdoktoral di BRIN. Kemudian riset bersama dengan peneliti BRIN. Kemudian untuk postdoktoral itu targetnya setahun 2, Q1. Jadi Dr. Manimaran ini kami targetkan untuk menghasilkan 2 artikel Q1 selama setahun. Termasuk ada satu program untuk visiting researcher. Alhamdulillah juga Dr. Anwar 1 bulan ini visiting researcher di kami, melakukan riset bersama. Nah itu juga ditargetkan. Setiap visiting researcher itu ada 1 Q1. Gitu. Jadi nanti barangkali Bapak-Bapak Ibu dosen yang ingin menjadi visiting researcher atau postdoktoral di BRIN itu bisa memanfaatkan skema ini. Nanti tentu kalau mekanisme di dalam kampusnya nanti mengikuti kampus UI, misalkan ada perizinan dan sebagainya. Jadi sekali lagi kami berterima kasih melalui kegiatan ini mudah-mudahan kolaborasi antara UI khususnya FMIPA ya Departemen Kimia UI ataupun departemen-departemen lainnya itu bisa semakin erat dan juga tentu dengan kolega-kolega dari internasional dari USM ataupun dari India ya dari Feria University India. Insya Allah itu mudah-mudahan sekali lagi harapan kami acara ini bisa berlangsung dengan baik. Sekali lagi terima kasih dan saya ucapkan wassalamualaikum warahmatullahi wabarakatuh.
Thank you to the warm welcome to the Dr. Dede. And then today's lecture will be given to Dr. Anwar with a theme mitigation of harmful algal blooms from a chemist perspective. And also will be accompanied by Dr. Tuti. Dr. Tuti, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. This is a beautiful day because we have an honorable guest from Malaysia and also from India and also Pak Dede from BIN. Welcome to Department of Chemistry, Universitas Indonesia. And today's lecture will be about the mitigation of harmful algal bloom from a chemist perspective from Dr. Anwar Iqbal. So as we know that water is very important for our life, not only for human, but also for animal and also the plants also, I think all of us, all organism need the water. So the quality of water will be important for us. So from this lecture, we want to listen the insightful speech from Dr. Anwar Iqbal, how the chemists find a solution to mitigation harmful algal blooms. Okay, so for this lecture, please welcome Dr. Anwar Iqbal. Okay, so okay. So for the presentation, maybe we can start now. The time is yours. Thank you, Dr. Anwar Iqbal.
All right. Assalamualaikum and very good morning. So thank you everyone, especially to Pak Asad and Madam Moderator for giving me this opportunity. So my presentation, my lecture for today, the title as mentioned before is Mitigation of Harmful Algal Blooms from a Chemist Perspective. So when I was thinking, when I was choosing a title, I was thinking that what title should I put that really portray what I'm doing and that can connect with other lecturers or other researchers from different fields. So, and then when I was looking at the big title here, which is harmful algal bloom. So if you scroll on over the internet or if you look for papers, so what you can see is mostly on the identification or monitoring of harmful algal bloom. And even though there are some papers that many papers have been published on the mitigation of harmful algal blooms, so it is not, the papers are not discussed fundamentally between the algae and the material used in mitigation takes place. So that is where the title from a chemist perspective comes from, because I'm interested in fundamental studies of how things work. All right. Before I go further into the discussion, I would like to introduce my university, where I come from. So as mentioned before, I'm from University Science Malaysia. So it is the second university in Malaysia in terms of ranking. All right, and we have a few campuses. So the main campuses is in Penang. So I'm not so sure, have you guys have heard about it or have been there? So it is a teeny tiny island on the north of Peninsula Malaysia, which is on top. So you have to use magnifying glass in order to see where the island is. So even though it is small, so it is like, it hosts about 3 campuses, 4 actually. So we have the main campus, and then we have the engineering campus, and then we have another like mini health campuses. We call it as Advanced Medical and Dental Institute. So that one is in Batam, which is on the mainland of Penang. And we have a health campus on the east coast of Malaysia, which is in Kelantan on this side. And we have another sister health campus in India, which is known as USM KLE, International Medical Campus, Belgium. And recently we have opened another mini campus, offshore campus in Turkey, or Turkey. Okay, so basically these a little some pictures that you have taken from the inside of School of Chemical Sciences. So basically on the outside, it's a bit, it is an old building, but inside the campus, it is relatively very modern. and we have many facilities, and all these facilities are being upgraded to suit the progress of time. Okay, so this is about myself. Actually, the person on the picture here and the person in front of you are the same. Okay, but because of COVID, and because of being grounded for 2 years, so you can see a lot of changes. So my research interest or expertise, I would say, is mainly on catalysis. I'm interested in kinetics and mechanisms of reactions, especially on the mechanisms part, and also in using material. Okay, so far this is the number of students that I have, that I personally, number of students as a main supervisor and also as a co-supervisors. Okay, now let's go back to the main part, which is harmful algal bloom. So harmful algal bloom, it can be defined as the proliferation of toxic and non-toxic microalgae, which can be divided into diatoms, okay, yang ini susah untuk disebut bagi saya. Dinoflagellates, rhapidophytes, haptophytes, pelagophytes, cryptophytes, then a few other macroalgal species, which can be green or brown. So as you can see from these pictures, just by looking at the pictures, you can get some ideas why this is called as harmful algal bloom. Why is it harmful to us? Okay, so you can see the color became green, and the color became red, and the color became brown. So just by looking at the colors, for those who are not aware, it can be something fascinating. For those who are aware, they know that when a color change, so it could be something dangerous might be lying behind it. So in this case, when the color change, several things can happen. Okay, so this is fish cages. This one is in Canada, if I'm not mistaken. Okay, harmful algal bloom, when it happens, it might be, there's several factors that contributes towards this event or towards the proliferation of these algae. So the main parts that have been widely known is through euterification, which is the process in which the entire body or parts of the water bodies are being loaded or enriched with happen. Okay, so the algae can continue to reproduce and bloom to a certain level that can cause harm towards us. And some of the algae, they can be either poisonous or non-poisonous. Regardless, they are poisonous or non-poisonous, they can still cause some, they can cause disastrous effect to us. Okay. Before that, allow me to mix English, Bahasa Malaysia, and also Bahasa Indonesia. So sekiranya Bahasa Indonesia salah, pengertiannya salah, minta betulkan. Okay, and then I just got to know this morning from Pak Asep, the algae, some of the algae, they also have the ability to convert organic phosphorus into inorganic phosphorus for them to, in order for them to continue surviving. So this is a new thing that I learned today from Pak Asep. And then another factors that contributes towards harmful algal bloom is global warming. Okay, when the temperature rises, it gives more opportunity for the algae to keep on growing, plus the nutrients, so it grows at a relatively dengan lebih banyak. Okay, however, there's also recently I came across a paper. So yang dalam kajian itu menyatakan kejadian harmful algal bloom makin tinggi bukan disebabkan oleh global warming, but it is caused by advancement in the monitoring and also in the identification of the algae. Iklan. It's okay. You try to keep it relaxed environment. Sebab saya pun nervous sebenarnya. Okay, so this is in general what causes harmful algal bloom. Okay, harmful algal bloom, it's a global phenomenon. So it happens everywhere. It can happen in the sea, it can also happen in the pond. I was also briefed by Dr. Asep this morning that there's a pond in UE. Okay, and you can observe the formation of harmful algal bloom, throughout certain months. So yang ini pada tahun 2016, I couldn't find the latest one. So you can see that this is on the toxic HAB toxic that has caused poisoning. So it happens throughout the world. So boleh, okay, you can see it is everywhere. It is almost everywhere. You can find it in US, you can find it in China, in Korea, and even in Alaskan Arctic. However, the good thing, the thing is, in US, in China, in Japan, Korea, they are very well advanced when it comes to studies or research on mitigation process. Tapi yang kalau di Malaysia maupun di Indonesia, we are more on identification and also on the monitoring. So setahu saya, to the best of my knowledge, tak banyak penelitian yang dijalankan dalam bidang mitigasi. Okay. Okay. Ini adalah keratan akhbar, okay, on the HAB events around Malaysia. So sama ada di semenanjung Malaysia, selalunya setahu saya kebanyakan yang terjadi di semenanjung Malaysia dan juga di bahagian Sabah. To the best of my knowledge, I might not I might made a mistake there, but it is an every year event, and bila sekali terjadi memang banyak masalah yang akan timbul, okay, terutamanya kepada fish farmers, because they are relatively in a fish, and the fishes are being constrained in a cage. And if let's say there's the event took place and some of the potential or the probability of the fish dying because of this HAB, because of this algae, are very high. And when the cage fish dies, again it goes back to the economic aspect, mana penternak ikan tersebut akan mengalami kerugian. So bukan dari segi aspek itu saja. When it comes to tourism, and they tend to again it goes back to economic loss, and it can also lead towards reduced quality drinking water quality, because of the poison, because of the foul smell and things like that. Okay, and this is a few papers and articles that I found in Indonesia. So it is a global issues that we need to tackle, because for one, because if you look in a single, if let's say there's a single HAB event, so the losses, as I mentioned before, can reach up to millions of dollars or ringgit or even rupiah. But instead, in addition to that, it can also affect the public health, in which one thing, people can get sick, can get poisoning if we consume the fish or the seafood that has been contaminated by this algae. Okay, so what is actually mitigation means here? So mitigation here, it means the action taken or action taken to manage the existing or ongoing bloom and taking steps to reduce the impact. Okay, as I mentioned before, in Malaysia and even in Indonesia, we are still at the stage where we monitor and where we identify the type of algae involved. Okay, and the mitigation strategies or the mitigation approach, we can divide it into three parts. The first one is by using a biological approach or biological method. So in which we can use seaweed, fish, virus, fungus, bacteria, plankton, you know, to kill the to kill or to control the growth of the algae. The second one is by using physical approach. When we can use the membrane filter, we can use sonification to kill the algae. And then the third category is by using chemical and chemical physical approach. So in chemical and chemical physical approach, so normally we either use chemicals like hydrogen peroxide or metal salt to kill the algae, or we can use clays, sands, adsorbent basically, in order to flocculate, to capture the algae and to bring it down and to sediment into the seabed, and also by using photocatalysis. So among these three methods, I am interested in chemical and chemical physical methods. So again, it goes back to the title, which is HUB, mitigation of HUB from a chemist perspective. So we will focus on this part today. Okay, the basic or the fundamental in applying this adsorbent is the interactions between the algae and also the adsorbent. So this method normally we use clays and modified. Okay, one of the reason is because it resembles the seabed. Okay, and it has been widely used in the field. Kalau di Jepang, kalau di China, kebanyakannya mereka menggunakan clays atau modified clays. Kalau clays dia kurang efektif berbanding dengan modified clays disebabkan kurangnya attraction between the algae and also between the adsorbent. So once bila berlakunya flocculation, okay, between the modified clays or sand with the algae, so it will form floc, so it will get heavier and then it will go down into the seabed. So modified clays or modified sand as it is, dia kurang berkesan. So sometimes we have to add in a new component which we call it as a modifier. So that's why we term it as modified clays or sand. And these modifiers, it can either be on the inorganic basis or it can also be organic basis. Okay, but most compared to inorganic, we would often go for compared to inorganic, we would often go to organic modifiers because it's deemed more safer compared to the inorganic. So basically the modified, the clays or the sand are modified so that it can attract more algae to flocculate and then to bring it down. Okay. Okay, dalam gambar, okay, dalam dua gambar ni, yang pertama ni dia berlaku ini iron nanoparticle is being sprayed onto the surface of the clay, onto the surface of the algae, water surface that contains the algae bloom. And then on the second pictures, it shows that the clays or the modified clays are being sprayed on the surface so that it can bring down to the it can bring down the algae to the surface. So kalau kita fikir, you know, kita masukkan something yang baru di dalam suatu kawasan. We are introducing a foreign substance in the ecosystem. Okay, and then it comes down, it settled down to the seabed. It is not retrieved back. So it is just left down there. So whenever you are dumping something new into the existing ecosystem, so there's a certain concerns or there's a certain issues that need to be addressed. So in this case, what will happen to the toxin that was produced by the algae? Kalau algae, whether is it, because if I'm not mistaken, normally the toxin will be released if if the algae got triggered. So in this case, we are triggering the algae. So when the toxin was released, what will happen to the toxin? Will it be brought down together to the seabed, or will it be just floating around on the water system? And then since the clay is going down to the seabed, so does it has any threats to the benthic community? Okay, so far if you go and look for the papers, they said that okay, it is safe, but in the long run, we are not sure. Okay. So and then the major thing is cost. You know, how expensive is it going to be? You know, to spray, you know, a huge area with clays or with chemicals. So it goes back to the cost. How much do we need to spend? Okay, if you go to the fish farmers, what they would do is during the hot season, so the local government in Malaysia, the local government will advise them to push or to relocate the cages. And relocating cages, again, it goes back to the cost, and it will also stress out the fish. So another option is is asking them to harvest the fish earlier. This is also a problem, because if let's say you harvest the fish earlier, the fish cannot be sold as much compared to the actual size that is suitable untuk dijual. So when I was thinking when I was thinking about all these issues, and then it's like, why not we come up with something with the material in which that we can use, effective to be used, and then we can collect back, or we can get it back at the end of the blooming season. So the first thing that I did with my team is by using silica. Okay, silica ada di mana-mana saja. So even in the papers, you know what they do is there's a paper where they took sand from the beach and then they dump it in the sea. So it is an interesting way, but I was thinking about why not use something from waste that has the similar properties. And we are not basically, if let's say you take a big chunk of sand from beach or something, it do have some effects as well. Okay, so in this case, we tried using silica from rice husk, and then we modify it using chitosan. Okay, so in this case, silica is biocompatible and chitosan is also biocompatible. So theory-wise, it shouldn't have any problem. And then we added in the chitosan so that it will increase the charge of the silica and make it more positive, so that it can attract the negatively charged algae. Okay. So a little bit on silica. Selalunya kita tengok beras, kita hanya nampak beras, tapi kita tak nampak sekam. Di sini panggil jerami ya. Nah, kita hanya nampak jerami dia saja. So dan jerami ni selalunya akan dibuang. So only recently, there's a publications that are going on, and even a production of adsorbent using jerami padi. So the jerami okay, sekam juga sama. So sekam padi, it contains about 90%, approximately 90% of silica that we can use, that can be easily modified and being used in various applications. So one of the things that we used here is as an adsorbent, or we call it as a mitigating agent to capture the algae. So di Malaysia, biomass ada pelbagai jenis, sama juga di Indonesia, tapi yang selalunya di Malaysia yang digunakan adalah oil palm biomass. So memang kalau kajian tentang oil palm biomass sangat banyak. Tapi walaupun silika pengeluaran even though the focus is very little, but it still has a huge impact on the environment and also when it comes to scientific research. So di Malaysia dahulunya selalunya kalau pada musim menuai padi, during the harvesting season, if you go past through the highway, you can see people burning the husk because they have no other means of disposing the husk. So normally we would obtain the husk for free. Kalau pergi dekat kilang cakap mau sekam padi, they would just allow us to take. Kalau boleh dia nak bagi semua because it will save their money. So from this, so there's a lot of plans that has been proposed by Malaysian government. So the recent one will be out. National Biomass Action Plan will be out in July 2023. So we'll just wait and see what is inside. What is actually the plan. Okay, silika daripada sekam padi dia boleh dikeluarkan atau can be extracted using two different ways. So the first one is solvent extraction method, and the second one is by using pyrolysis at high temperature. So yang ini pyrolysis at high temperature dia lebih mudah. So basically you just put it in a furnace, heat it up at a high temperature, and then to remove all the organics, and you get a rice husk ash, which is the silica precursor. And then on the second part, on the second method is solvent extraction method. So basically we use a alkaline solution to extract the silica out, okay, in a form of sodium silicate that we can also convert it, that can be titrated through sol gel extraction method. You can get the silica, and then the residue here, rice husk, selalunya dia, once the silica has been extracted out, the husk, dia akan jadi, it can be brittle. It is brittle, it is crumbled, so it is full with carbon skeletons, carbon compound, which we can turn it into carbon quantum dots, one of the method. So we managed to do this, and I'm still doing some research on it to optimize the extraction, the synthesis of carbon quantum dot process. Okay, now let's go back to mitigation. So in the first when we viewed the RHA, the silica without the unmodified silica under the microscope, you can see that it is very glassy-like. And then once we modify it with chitosan, you can see there's a morphology change. So it become more more disordered, which could increase the potential of the algae to attach itself on the silica surface. So the thing is, the keyword here on how to modify the silica is on the silanol group, on the OH group of the chitosan, and also the OH group of the silica itself. So through condensation reaction, so basically we can link, or we can bond these two chemical components into one to form one silica chitosan composite. Okay, and in the initial study, in the first study for the mitigation of harmful algae, the algae that we used is Alexandrium tamiavanici. So this one is commonly found in Malaysian waters. So the study was carried out in a petri dish. So basically you take a petri dish, we grew the algae, put the algae, and then we put the agent, in this case the silica chitosan composite, and then we see what happened. So this is the algae cell, Alexandrium tamiavanici, on the silica surface. So as you can see that nothing happened. It remained intact. But in the presence of chitosan, the cell undergo lysis, or it just ruptured. Okay, this is because of the rupture. Again, there's a big question mark here is what happened to the toxin. So we are still struggling to find out, to study the toxin in this case. The removal efficiency was very good. It was about 50% within 2 hours because there's a lot of contact. Yeah, because the mitigation studies was carried out in a petri dish. There's a lot of contact between the algae and also between the composite, so which increases the removal efficiency. However, we also noticed that in this case, the pH of the seawater reduced significantly, and the composite sink as well. So when pH reduced, it is not a good sign, okay, because it affects other marine organisms as well. So we want it to be, we don't want the pH to reduce significantly, to reduce or to increase significantly. We want the pH to be in a safe range for the, you know, for the marine other marine organisms to continue living. Okay, so that was the first attempt, which we know that something is happening, but we are not so sure what is it. So we have decided to go for the second attempt, in which we modify the silica with glycerol and also 3-glycidopropyl trioxysilane. This is an organic modifier that we used to modify the silica, but we did it in a phlegm form. Again, together with the chitosan as well. So the reason is we want to see whenever we change it into a film, we want to see what is the swelling properties or what is the cross-linking degree that is needed in order for the algae to be captured. Okay, so the film was made using solvent evaporation method, and then the mitigation studies was carried out in a 250 ml water. Seawater 250 ml beaker. Tadinya daripada petri dish. So we see some results and then we move on into 250 liter. Okay, so again we use the same algae. Okay, and this is how the film looks like. So if you look from the picture, you can sense that the film is, one thing, it is ugly. Okay, tak cantik. But it serves the purpose, and you can see that it seems so hard. Okay, the reason is we want the film to swell in the sea when it comes into contact with the water, and we want it to capture as much algae as possible. Okay, again, we utilize the concept, we utilize the hydroxyl group of the silica and also the one that is in the chitosan in order to form bonding. So in this case, we use glycerol. So as you look, this is just a partial, it's just like a scheme, you know, indicating the composite that was formed between glycerol and also the chitosan and silica. So kalau tengok dari sini, you can see that you can imagine, chemistry is about imagining things. So whenever you look at the structure, you train your mind, you know, to imagine how does it looks like in a bigger picture. So dari sini, daripada yang image ni, from this scheme, you can see that as the you can see that if you link all these components, it will form like a big net. So this big net, it has a lot of functional groups that can draw the algae towards itself through electrostatic interactions. And then since it swells, so it will also help to capture. So that was our first hypothesis. And then when it moves, okay, this is the SEM image of the films and its cross section. You can see that this is chitosan only. This is chitosan silica. There was like no change. But then when we added in the GPTE, the glycerol and also the 3-glycidopropyl trioxysilane, you can see that the surface become rough and uneven. So this could be a good indication as an adsorbent to capture the algae. Because if let's say the adsorbent surface is too smooth, the adsorption or the interaction would be lower. If it's like uneven, then the pollutant can easily being adsorbed on the surface. So in this case, we have tackled one issue. Okay, so this is how sorry, how much of the algae that can be removed over time. So if you look at the figure, you can see that the graph is going up and down, up and down. Okay, so this indicates that some of the algae are being absorbed initially, and then after some times it is released back to the environment. So when we did the swelling index testing, we notify that the silica chitosan composite that contains glycerol, it has a higher swelling index compared to chitosan silica that contains GPTE-OS, or the 3-glacidopropyl tritoxysilane. And if you look back at the graph, you can see that the one that have glycerol, the removal efficiencies is kept on going down. So it shows as the film swell, so the initially absorbed, the initially trapped algae, it tend to be released back into the environment. So you can see that there's a correlation between the swelling, the cross-linking, and also the removal efficiency. And then when we looked at the algae under the microscope, we can see that the one that has only chitosan, the cell ruptured. Whereas when we have modified with glycerol and also the GPTE-OS, 3-glacidopropyl tritoxysilane, so it shows that the algae cells are preserved. So it means that initially I mentioned that the amine group of the chitosan is causing the distress to the algae. So in this case, it shows the combination or the cross-linking between the glycerol, between the 3-GPTE-OS, 3-glacidopropyl tritoxysilane, could have happened through the amine group as well. So in glycerol, it is not that obvious, the preservation of the algae. So again, whenever we are using adsorption, we have to look for the PZC, point of zero charge. So point of zero charge of the material is where the positive charge and the negative charge is equal. So in this case, when we investigated the PZC of the chitosan material of the film, so it is between 4.3 to 5.5. If let's say the medium of the reaction, so in this case is the seawater, if it's higher than the PZC, the surface of the adsorbent will be negatively charged. Whereas if it's lower, if it's higher, it will be positively, okay, correct. So if the PZC value is higher compared to the seawater, so it will be positively charged. If the PZC is lower than the pH of the seawater, it will be negatively charged. So the pH of the seawater that we used was around 6.8. So this shows that the surface of the film is negatively charged when the mitigation reaction was carried out. Okay, so now you can see that the fluctuation, the fluctuation in the removal efficiency could also be due to the PZC of the adsorbent. Now it is negatively charged, the algae is negatively charged, so they tend to repel. So at the end, concentration, removal efficiency will be affected as well. Okay, this is the phlegm, the used phlegm after we mitigate. So compared to clays, compared to sand, you can see that the phlegm, the clays or the sand, it tend to get sedimented. So kita tak boleh recover back. But this this membrane, it can be recovered at the end of the experiment, I would say, at the end of the experiment. So this would save, in a way, it saves the environment. the aquatic environment, because we put in something foreign and then we take it out at the end of the mitigation process. And if you notice, if you compare the phlegm, the fresh phlegm with the used phlegm, if you can still remember how it looks like. Initially, before the mitigation process, the phlegm was very clean. Okay, it looks smooth and it just looks smooth and uneven. So wherever after the mitigation process, you can see the changes in the morphology of the phlegm. Okay, so each phlegms, the chitosan silica, the chitosan silica glycerol, and also the chitosan silica GPTOS has tremendously changed. So this change is due to the attachment or the entrapment of the algae on the surface, entrapment on the phlegm. Okay, and then again, now we have created mass. We have created waste, sorry. We have created waste. In this case, which is the phlegm. So what are we going to do with the waste? How are we going to dispose the waste? So since it is based on silica, it is based on chitosan, so it has a high biodegradability, but high level of biodegradability. So because of that, we tested, how long does it take for this phlegm to decompose when we bury it? Okay, so basically it took about 30 days to be completely dissolved in the soil. So again, this is the plus point of the phlegm. Is that an indication for me to stop, or? Yeah, I'm just joking. All right. Okay. Okay, and then now we have in my third or fourth slides, I mentioned about using photocatalysis in mitigation. Okay, so we have also tried to incorporate TiO2, titanium dioxide, which is a widely used semiconductors in photocatalytic reactions. So normally when it in photocatalytic reaction, so what we use is we try to degrade dyes, we try to degrade antibiotics, so basically pollutants. Okay, there are many. We can also use this TiO2 in order to deactivate the algae as well. Okay, but in papers normally the TiO2 that was used is not immobilized. Dia tak diletakkan di atas apa-apa substrate. So just like we sprayed as well, but there's a certain papers that has cited that shows the TiO2 that was used, it tend to be consumed by marine organisms and it stays inside the body. So in this case, so based on that, what we did was we incorporated on the chitosan phlegm. So to make it if before this is like chitosan silica hybrid phlegms, now we are in chitosan TiO2 hybrid phlegm. Again, the phlegm was prepared using solvent casting method, similar to the silica, and the mitigation process was also done similarly. Okay, the phlegm looks similar to silica, but it looks similar to silica, and then again, the cross-linking is also based on the hydroxyl group. Okay, through condensation reaction, we managed to link the precursors of TiO2. In this case, we use TTIP. Okay, so it forms the reactions between the chitosan and the TiO2. It forms a TiO carbon bond. So it shows that it is the TiO titanium is linked with the skeleton of the carbon. Okay, this is the image of the phlegm in the presence of the algae cell. So similarly, you can see that all the algae cells are preserved compared to chitosan phlegm only. Okay, again, you can also notice the structural change, the morphology of the phlegm change in the presence after the mitigation process. We are still trying to identify how the algae breaks how the algae lyses, and how does it change the morphology of the films as well. Okay, again, we also notice the fluctuation. Okay, however, in the presence of TiO2, the swelling of the film is higher compared to silica, but the removal efficiency, even though it fluctuates at the end of the study, it is high compared to silica. So again, why? So the main difference between silica and TiO2 is the ability of TiO2 to generate radicals. So what these radicals can do is it will cause distress. The radicals that was formed, it can cause distress to the algae and deactivate it, and causing it to um, and catalysis. So whenever we are using TiO2, so in the presence of light, so the electron will be excited from the valence band, from the conduction band to the valence band. And this electron, when it got excited, it will leave behind holes. So these electrons and these holes, it plays a major role in photooxidation or in photocatalysis, because the electrons, it can react with the oxygen, the holes can react with the water, and it will generate radicals. So these radicals in turn will go and cleave bonds and will cause distress. In this case, to the algae, if let's say there's an organic pollutants are involved, so it can go and cleave the the organic pollutant. Okay. Similar to the silica composite, chitosan silica composite films. So the films, the chitosan the chitosan TiO2 film. Hang. No, I guess it's hang. Okay. Can you go back to the few slides? Go back some more. Back. Ke belakang slide. Okay, if you notice, similar to the silica. Okay. Okay, we are back. So similar to silica chitosan film, so the chitosan TiO2 film can be disposed by burying it in soil, and within 30 days, so the film was completely gone. Now we have, since based on the results that we have obtained, so we have moved on into another stage in a larger scale. So from petri dish, from petri dish to 200 ml beaker, now we are in 10-liter aquarium. So we have synthesized a few different types of films that indicates that are showing a good results. So the preliminary results from this experiment is that one thing, we managed to make the film positively charged. Okay, and some of the films are showing showing some indication that it didn't submerge down. It didn't not just it floats. Okay, it floats on the surface of the sea. So which shows that it can be, which indicates that it can be easily separated at the end of the mitigation season. So that's all on the mitigation part. And also I would also like to include a little bit of my works related to silica from rice husk ash, from rice husk. So while doing work on mitigation of HAB using silica from rice husk, I'm also interested in utilizing it as a support for metal, for metal and non-metals in for fine chemical synthesis. So normally what we have done so far, is we used silica that was extracted through solvent extraction process, solvent extraction method, and also silica that was obtained from pyrolysis process, and modify it using various types of metal. So in this case, we synthesized a catalyst for oxidation of styrene using chromium, molybdenum, and tungsten. So it shows that this catalyst, it can effectively catalyze the reactions and to give a comparable conversion related to what have been commercially being catalysts that are commercially being used. And we also modified, we played around with the acidity of the surface of the silica and use it as it is, without adding in any metals, which forms a different that gives a different porosity. So in this case, we have microporous silica, and it shows a good reaction as well. Again, we utilizes the hydroxyl of the silanol group of the silica in order to attach the metal, or to attach the metal, or we modify it by to make the silica participate in a reaction instead of just as a carrier for the metal. So in this case, the silica act as a catalyst. So we have also used for various reactions, for oxidation reactions, and this one is in the Friedel-Crafts benzylation reactions of toluene. The silica was impregnated with zinc chloride, and we also have other types of metals that have been that have been added into the silica that gives different types of morphology and gives a good results in the fine chemical synthesis. Okay, and another part of research that I'm really interested in is in quantum dots. So quantum dots is basically nanocrystal semiconductors, and the size ranges between 2 to 10. And the beauty of this quantum dots is that they can give a lots of colors, different colors, different interesting colors, depending on the size of the on the size of the particle of the semiconductors. So the smallest is blue, whereas the biggest is red. So because of these colors, it has been used widely in electronics, in solar cells, and also used in bioimaging. So initially we have tried to incorporate zinc oxide quantum dots into LLDPE TiO2 hybrid polymer films. Again, it goes back to the film. So initially, just now I used the film to capture the algae. So in this case, I also use the film, to photo oxidized pollutants. So in this case, the pollutants that I in animal husbandries. So again, it utilizes a photocatalytic concept. And so we fully utilize the electron and also the holes from the holes that was left out when the electron excited from the valence band to the conduction band. So we in photocatalysis, because we want to generate the radicals, we want to keep it the electrons and also the holes as far as possible, as long as possible. So when we do all these modifications, we are actually creating a different path for the electrons, especially for the electrons to move on, to flow before it reaches out, before it meets back with the holes. So once they meet back with the holes, the radical generation will not take place. And we can use the film we use it up to 8 cycles without noticing any reduction in the photocatalytic activities. So these are the examples of the zinc oxide quantum dots that we have prepared and immobilized on the polymer film. Okay, this one is on carbon quantum dots, modified GC3N4. Again, it uses the same concept, which is photocatalysis, which is electron, which is the excitations of the electrons, the formation of radicals. So these radicals, it serves a significant role, a huge role in our application, whether we want to degrade the algae or whether we want to oxidize pollutant. And this is an ongoing works on zinc oxide quantum dots that we used as a sensor to detect tetracycline and ciprofloxacin. So it seems that you can see both tetracycline and ciprofloxacin, they have different structures. And because of these structures, it is affecting the ability of the detection of the zinc oxide quantum dots, which was initially yellowish color, and then as we increase the concentration, the color changed, whereas for ciprofloxacin, it remains blue only, regardless of the concentration. So the main question mark here is why this is happening and how this is happening. So this is the currently work that I'm going on. So that's the end of my lecture for today. So now let's move on. I would like to move on and to express or to invite, the collaborations between Universitas Indonesia and also with myself in PPS, in School of Chemical Sciences. So we can collaborate by co-authoring papers, by student supervision, material analysis, and grant applications. So I got to know Pak Dede through this process. I hope I will get to know, docent or lecturers from UE through this process as well. And then the other parts that I'm really interested in is, this one is Depok, not Bogor. I got confused. So as a guest, know how I can come here and get to know Indonesians better. Okay, my almost 1 month in Indonesia has been very pleasant, and I would like to extend my stay, and I would like to learn more about the Indonesian culture. So one of the things that we can do is that I feel like I can contribute back is by becoming a guest lecturer in UI. So basically, I've been teaching inorganic chemistry 1 until in organic chemistry 3. This one is for S1. And then for S2, so I have been teaching nitrogen absorption analysis, and in my university, so there's a topic, or there's a course that we call as surface and thermal analysis. And these are my past and current students. So the one on top, they have already finished. So Dr. Kok Hao, he is now in Taiwan. Fatima and Usman is back to Nigeria. The work that I've presented just now on mitigation of harmful algal bloom is from Miss Hanisa's work. So it is her master work. Then I have like 3 ongoing. These 2, Ehab and Amal is a PhD students of mine, and we have Sami. So, and I would like, that's all I guess. I would like to express my gratitude to University of Science Malaysia and to BRIN through program visiting researcher batch 2 2002, especially to Pak Dede. So this is, to get my picture together with Pak Dede's team in BRIN, and not to forget Universitas Indonesia for giving me this opportunity to share a little bit of my knowledge, and hopefully it will be beneficial to all of us. Thank you.
Okay, thank you, Dr. Dr. Anwar. Okay, for your nice presentation. So from the presentation, we can know that the impact of algae bloom is very significant, not only for the public health and also for the animal feature in the sea, and then also for the minor for the farmer ecosystem also. That's all will be impacted by the algae bloom. And then we also, from the presentation of Dr. Anwar, we know that we can use the biomass derived compound for the mitigation from the harmful algae bloom. So now maybe we can continue for the discussion. Maybe we will have 3 sessions. For each session, we will have 2 audience who will ask. Please, for the first session. Any question? Any question from the student? From the online, okay? From the online participant, maybe. Okay, so we have 2 participants from the online, from Zoom. Okay, so first, please Muhammad Ali Abdullah. To tell your
hello, excuse me.
Yeah.
Is my voice being heard? Is my voice clear? Sorry.
Yes.
Oh, okay. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, I would like to thank you, Mr. Anwar, for your very interesting presentation regarding harmful algal blooms. I thank you also for the opportunity to raise a question. I would like to ask, in your first parts of the presentation, you said that TiO2 can be used to create reactive oxygen species to make the bacteria, to make the algal lysis. Is that correct? So, Mr. Anwar.
Yes, sir. So TiO2, yeah, you're right. TiO2 can create reactive oxygen species.
Yes. So my question is, will the reactive oxygen species also affect other the microbiome? So not just the algae, so other bacteria or even other larger creatures such as fish, or is the reactive oxygen species will only target the algae.
Okay,
that is all.
Okay, thank you, Mr. Alif. So the ROS, it is not specific. So whenever it was produced, so it will go after not only algae. So there's a possibility for it to go after other marine organisms. Yet, but in my research, we have not reached that stage yet, because we have only investigated on the ability of the film to mitigate HAB. So that is another area that we will have to look at before it can be implemented in the field. I hope I have answered your question.
Yes, Mr. Albert, that has answered my question. Thank you very much. Because I was thinking if the catalyst produces too much ROS, wouldn't that also damage or also kill other marine species, the same as the harmful algal bloom itself? So it's not really solving the problem. That was my line of thinking. Thank you very much.
Okay, thank you for Ali for your question. Next, the question from Aldo.
Yeah, thank you so much, Bu Tuti. First of all, thank you so much, Dr. Anwar, for your presentation today. It is very interesting, especially for me, because I also working on algae right now. From algae, working on natural peptide producing in algae. And then I would like to ask about your Kitasan silica based flocculant that you use for mitigation of algae, harmful algae. Is there any, from your research, from your data that you have been collected, is there any cutout size, or is there any like physical characterization of the algae that is able to be separated from the water sample? Because as we all know, flagellates and diatoms are typically more larger than, for example, chlorophyta based species that is more smaller in size. And then I was also would like to ask about the mitigation around the exopeptide that has been secreted. For example, here in University of Indonesia, most of the species that has been bloomed over the years is Plantotrix, that is typically producing a lot of toxins in the form of like peptides such as saxitoxin and a lot of other stuff. I would like to ask: is your method is also work for the natural the peptide that has been secreted, or are we need to think about new sources, new method to mitigate the toxic peptide that has been produced after the algae has been cleared from the water sample? Thank you.
Okay, thank you, Mr. Aldo. So far we have only used Alexandrium tamiavanici, because that is the only algae that we have in the stock in Fisheries Research Institute, Penang. So we are also trying and use the algae to use different types of algae and see whether it works or not. So last week we went to Brin and Chol, and then we met a few members of Ancol, especially we met Ibu Hikmah Toha. I think she is in the in the crowd as well. So we have discussed also the possibility of trying it on using other algae and see whether it works or not. Okay, and then about the toxin. Okay, TiO2, it produces radicals. So these radicals, it can also degrade the toxin, similar to what similar to photooxidations of antibiotics and other organic pollutants. However, we have not reached the stage where we looked at into the toxin as well. So it is an ongoing research, and there are lots of places that we have to, a lot of things that we have to look into. So this would be a great area for us to collaborate and see how we can come up with a better agent that is being able to tackle all these issues. I hope I have answered your questions as well.
Yes. Thank you so much, Dr. Anwar. Thank you so much for your answer. I understand there are a lot of room for growth, but by then I would like to wait for your next future endeavor. Thank you so much for your information.
You're welcome.
Okay, thank you, Aldo. Is there any question from the audience? Okay, yes, please.
Is it my turn? Okay, Assalamualaikum warahmatullahi wabarakatuh. Thank you for the opportunity. I am Haritz Atika. I was graduated from Department of Chemistry, Universitas Indonesia, and currently I'm working in Universitas Gunadarma. So I'm very interested with the research of Dr. Anwar in algae. I have some question because currently I'm also working in aquaculture based startup. So I'm working very close with algae, and we have some problem with algae. And my question is, as we know that some algae produce toxin during, I call it with sterilization process. And my question is, do your methods also analyze the toxin produced from the algae, or just make sure that the algae is reduced? I mean that, can this method destroy these toxins? And also, the problem faced in aquaculture is the very large need in the aquaculture, because we need big material in around 4 hectares per pond. So what are the next steps if this method is to be ready to apply in the real ponds? So how about the cost? Because if going to the industry, we will also talk about the cost. Thank you.
Okay, to answer your first, thank you, Haris. We meet again. Actually, we sit next to each other inside.
Okay.
Inside the lab back in Brain. Okay, Haris. The toxin produced, the radicals should be able to degrade to break down the toxins, but the extent or how good it is, we have not reached that stage yet. Okay, we are still on trying to improve the ability of the film to capture the algae. And because of due to limited funding, then when I started this project, we were at the beginning of COVID. So we have to push the toxin, the analysis of the toxin in the future. So maybe after this, once I get the result, I will share with you, inshallah. And then to answer your next question is the next step in utilizing the film in a bigger space. I have been wondering the same thing as well, and we have a few a few options that we can use into it. So one of the options that we can see is by once we get the film optimized, so we have to go for a prototype. We have to create a structure or a model in which the films can be fitted in and can be used. At like a vacuum cleaner to go around the pond and then do the mitigation. And it is possible, since we have sun, we have lots of sunlight, which we can use it. We can use it to operate, the vessel using solar system, which can goes around and try to to kill as much algae as possible. So I hope I answered my question. Your question, sorry.
Okay. The time maybe we can talk about this in another opportunities. But thank you very much.
Okay, you're welcome.
Okay, thank you, Haris. And then the next question from the audience from Gedung C.
Thanks for the presentation, Mr. Anwar. And I'm Cleoni, want to ask a little bit about the topic. And you have mentioned the first attempt that chitosan nanoparticle would be an alternative to entrapping the algal bloom. Then we all know that one source of chitosan is crustacean skin. Then my question is, how do you control the toxicity given chitosan because of chemical modification process? Degradability, since animal testing remains a viable option to ingredients testing. Thank you.
Okay, thank you for the question. So you, if I understand correctly, you are asking the toxicity, right? The toxicity of the material that I have made. Okay, so far it shows it is non-toxic. We have carried out preliminary toxicity studies, so the material that was produced is non-toxic. And when it comes to lower molecular weight and also the higher molecular weight of chitosan, we have not tested yet. So it is an ongoing research on utilizing the low molecular weight chitosan and also the high molecular weight chitosan, and see where is the effectiveness lies. There's a lot of question marks. There are lots of questions that I need to be looked into, and one of that is the toxins and also the molecular weight of the chitosan. I hope I answered I hope I have answered your question.
Okay, thank you. Is there any question? Any other question from the audience here? Okay, so I'm interested that the chitosan and its modification will swell. Okay, so is the interaction between the algae and the chitosan only electrostatic interaction, or also involve the like a physical entrapment?
So it can be both physical entrapment and also the electrostatic. But if let's say the electrostatic is strong, so it can draw the algae towards itself, and the physical entrapment can take place at a better rate compared to just one interactions only.
Okay, so what about other hydrogel like alginate or carrageenan? the potential for the mitigation of the algae bloom?
It is possible. Whether I'm not so sure the effectiveness, whether you want to use it as it is or you want to incorporate with chitosan.
With other like with the silica maybe?
It is possible. It is possible to cross-link, and then we can investigate and see.
Okay, because you mentioned before about the chart is also important for the entrapment. And also, we know that the algae blooms not only happen in the sea, but also in a fresh water like a lake. And we know that both have a different pH. And then from the chitosan and its modification, what do you think? It's more effective in the seawater or the freshwater environment?
It depends on the pH, but normally for an algae to survive, if I'm not mistaken, correct me if I'm wrong, so the pH is within 6 to 8 for the water. So if let's say the lake has the same pH as the sea, or in between it, then I think the phloem might work as well.
Okay.
Because all this while we have only focused on the sea, because that is the only culture that we have.
Okay.
Or
Is it
the one in
using
the
the
sea.
natural seawater or
Yeah, natural seawater.
naturally
Yeah.
seawater? And the pH is
About
6
6 to 8, 6.8. The one that we have, the one that we
6.8.
tested is 6.8
Oh, is it from Malaysia or
from
from
Malaysia.
Malaysia? Okay, because some literature also mentioned that the pH of seawater around 8,
8, yeah.
8.1. So
Yes,
a little
a little lower.
acidic,
Yes.
acidic than the normal. Okay. Is there any other question from the audience here? Okay, so I think that's all for the lecture today. I hope all of you, all the audition can take a benefit what Dr. Anwar has shared to us. And this is very insightful, not only for the audience and also for me. So we can see that our bio-based material and like chitosan and also the silica can be used to mitigate the algae bloom, which is it. This is for the better future for the environmental in especially for water. I think that's all for me, and then I will return to the MC. Thank you, Dr. Anar, for presenting this lecture.
You're welcome.
Okay, thank you to Dr. Anwar as a speaker and Dr. Tuti as a moderator. And the next session is and take the photo session together. Okay. Okay, thank you to Dr. Asep and Dr. Anwar. And the next session is photo session together. So for all the participants, please come to the front and we take photo together. Okay, thank you to all the participants, and we really hope to see you in the next lecture guest again. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.